Good morning, everybody. On number 15, these ones get a little bit nastier just because we start involving base E, which is an irrational constant, kind of like pi is. So it behaves in the same way as other bases in math span problems. So if I look at number 15, we see that we've got multiplication going on between our two bases. So the m to the a part of MathSpam says that if we are multiplying, we are going to add these exponents together. So 2x plus, a binomial power, our base remains e, and 2x plus 5x is 7x. And then the negative 1 stays negative 1. Now, a lot of times students look at that and go, negative exponent right here. Shouldn't we try to resolve that bad attitude and move our base to send it to the downstairs and resolve it? This actually is our final answer, and it has to do with the fact that our power actually has an exponent with it. So anytime you have a variable in the exponent, you are going to leave negative powers. And the reason why we leave them alone is because they are going to vary with the variable. Vary with the variable. So what this means is, even though this is a negative 1, depending on what x is, maybe the exponent as a whole will end up negative, but maybe it'll end up positive. For example, if our variable was 0, then our power would end up being negative 1, and then we would send it to the downstairs to resolve that negative exponent. But if we had x as 2, then 7 times 2 would be 14. 14 minus 1 is 13, and e to the 13th is a positive number and not a bad attitude. So as we start looking at variable exponents, you won't have to do as much with those negative powers. Now, looking at the next problem, I'm going to ask it again, similar to how I did on the previous page. Is this a foiling problem? It is multiplication, and we do have lots of different pieces going on here, but this isn't a foiling problem because it's not a binomial times a binomial. We simply have two monomials, 3e to the negative x times 5e to the 5 minus 2x. So all of this stuff is joined by multiplication, so we simplify it by multiplying like terms. So 3 times 5 are like coefficients. That gives me 15. Now with our e's, since we are multiplying those bases, MathSpam says we are going to add those exponents. So negative x plus a negative 2x is negative 3x. And then we've got the plus 5. And order doesn't matter. You could just as easily have e to the 5 minus 3x. Looking at the next one, so getting back into division here, we've got 5 divided by 2. So that 10 divided by 5, which simplifies to be 2. Now, looking at our base e's, we are dividing the bases, so we are going to subtract the exponents. So I'm going to go ahead and write this one out. I'm going to have my top power, x, minus my bottom power, x minus 3. And I have intentionally made a mistake here, and hopefully somewhere out there, one of you watching this is thinking, parentheses, Mrs. Cairo. We have to enclose that x minus 3 in parentheses because I am subtracting that whole thing from that top exponent of x. So distributing that negative, we get 2e to the x minus x plus 3. So those x's are going to cancel each other out, and our final answer is 2e to the third. All right, moving on to our final problem. We've got e to the x times 5e to the negative 3x raised to the 2x. Now, on this problem, it's important to think about PEMDAS. Where we are going to start depends on the good old order of operations. So, do I have parentheses? Sure do. But if I look inside those parentheses, can I simplify 5e to the negative 3x at all? That is a no. So what I'm going to do is move to my next part of PEMDAS, which is the e part, or the exponent part. So looking at my exponents, I'm looking at my power rules. So if I've got 5 times e to the negative 3x powered up to the 2x, we are powering up, which means we are going to multiply those exponents. Now here's the tricky part. How many exponents do I actually have in this parentheses? We've got the negative 3x as a power, but that coefficient of 5 also has an implied power of 1. So I'm going to distribute that 2x to both of those powers. So notice who's not getting that power of 2x, this e to the x that's floating on the outside of that parenthesis. So that's going to stay e to the x times, so I'm not going to distribute that in. We're handling the exponent first, and that gives me 5 to the 2x, and then e to the negative 6x squared. Ugh. So now, looking at PEMDAS, we move on to the multiplication part. We've got 3 different bases, all joined by multiplication, and 2 of those bases are actually the same, base e. So since they are joined by multiplication, we are going to add those exponents. Now, if I look at those exponents, can I actually add x to negative 6x squared? Nope, because they are not like terms. So I still write them as being added together, negative 6x squared plus x, but there's no way for me to simplify that expression. I mean, you could factor out an x, but it doesn't really do anything for us. Now, with the 5 to the 2x, we actually can simplify this by simplifying 5 to the second, which is 25, and then that is still raised to the x. And that is as simplified as this nasty expression will go. So that would be our final answer. So the reason we can't do anything further with this one is because e and 25 are not like bases, so we can't do anything with the exponents. So folks, that's where the content starts for lesson A in this unit. Now down at the bottom, you will not be responsible for knowing anything from lesson B with these exponential growth and decay models. You did see these just a little bit in Algebra 2, but just one quick thing I want to talk about is exponential functions. This is a review from the chapter that we did with parent functions. If I think about an exponential function, does that have a horizontal or a vertical asymptote? Horizontal. And its domain is all real numbers, or darn. So all real numbers, negative infinity to positive infinity. And the reason why I'm bringing this up is just because remember that log functions are the opposite of this. They have vertical asymptotes and a range of all real numbers. So that's just something we're going to talk about a little bit later, but otherwise you do not need to know any of this stuff. Same with on the next page. If you are looking at the original note packet, you do not have to know that. Or the next few pages, so nothing from that one. Or this one, so lesson C, we're actually going to be skipping as well. Logistic functions, I'm kind of sad we're skipping these because they are kind of interesting. So again, folks, any of this stuff we are skipping, you'll be fine without this stuff for calculus, but if you are curious and you don't have things to do, hopefully you're outside enjoying this nice weather, but if you want to look a little bit further into this, you can go back to our original note packet pages and you can see the notes over these functions. So where we are going to be resuming in the next video is on page 8. So I will see you there.